Hello everybody, this is a video reviewing lab number 5. And hopefully if you're watching this video, you're aware that you should be watching the video for each lab before you actually do the assignment. And so outline the steps in SPSS to do a one-way Anova. I probably should have opened some data, but it's pretty easy. If you remember it doesn't matter what I'm going to open up, although I think the sleep is what we were doing repeated measures for. So I'm going to show this in a second. So remember, it's analyze, compare means, and then it's one-way ANOVA. I do want to show this, so I apologize for this slight delay. And I'm hoping it's a slight delay. You can fast forward. Oh, now we're here. And so the steps are analyze, compare means, one-way ANOVA. We click that. And actually, we were using something else for this, but yeah, I feel like I want to use the appropriate thing. So I'm blanking in a second here. Yeah, we have the age categories in this file. So analyze, compare means, one-way ANOVA. So we were looking at the age category, and that's a factor. So whatever the categorical variable is, the nominal variable, the group variable, put as a factor, and then we have a dependent. So what are we looking at in terms of comparing those three groups are on in terms of what thing? And I think there's a sleep thing here. Sleep last night, I believe, is the correct one. So again, our independent or predictor variable, which is the nominal level, goes into factor. Our dependent variable, which is at least approximates interval or more, so it could be ratio. And then we press post-hocs because we need to do post-hocs, and we've been doing Tukey in this class, and then you press continue. And then you do options to get the descriptives. And so that's how you run an ANOVA test. And I don't think I need this. So I'm going to close SPSS, au revoir, mon frère. And question 2. So before that, it says, look at the outputs. You need to look at the outputs. And parts 1 and 2 are for question 2, and 3 and 4 are for question 3. When you watch the video for the labs, it also explains that. So we're just going to we have to write up the sentences, the result sentences. So we want to include a sentence for effect size. But we aren't doing a confidence interval. We don't talk about that in the ANOVAs. In some ways, because it would be fairly complex. And make sure to have our tables for descriptives and standard deviations and the ANOVA summary table. So we're going to look at the output 1 and 2. So 1 always is going to give us the descriptives and the F-test stuff. I want to draw on this. So I'm going to snip it, and I'm going to draw. So this is our output with the descriptives and the ANOVA. And so I'm going to do two things. I'm going to go over how I sort of go and do this and do the interpretation quickly, and then I'll go over how you get the stuff from or the sentences you need to write up. So I'm just going to say, what do I do when I see an output like this? First thing I look for is this. I go bam straight to this because I know that significance, if this is less than 0.05, then I know we reject the HO. So my first question is, is there an effect? So I look at this first. And everything else, it doesn't really matter in some ways, but you see it's significant. So remember the sig here, and this is actually a appropriate one-tail sig, if you will. There's actually no tails in ANOVAs, to be quite truthful. So there's no tails. It's just are there some differences? And so the sig gives us the exact percent of a type 1 error. And here, I shouldn't say exact, because here I have something that's all zeros, and there's no such thing as a zero, but we're talking about, remember we moved this thing down to get the percentages, so we're talking about a less than 0.01% chance that there's a type 1 error here, so it's highly significant. So I look at that thing right away, and I know it's significant, so that's the thing I care about. So I'm going to snip this again, and I'm going to go over how you're going to get the information to write your sentences. And again, by the way, if you don't like using that easy way of just using that sig, the significance, if you want, you can go ahead and take that F that's displayed in the table and take the degrees of freedom between, degrees of freedom within, and go ahead and look it up in the critical value table and make your judgments that way. But it's going to take longer, and the decision is the same. But you could do that if you wanted to. I just think it takes a lot of extra time. So again, if you wanted to look at this F, 9.92, and then go to the table to get your critical value, here's the degrees of freedom between, that's the column, degrees of freedom within, you can find the critical value there and compare it to this F, and you'll find the same decision that you rejected HO. So let's go ahead and talk about the sentence that you're supposed to write, or sentences you're supposed to write, and the tables. And so the first thing I'll do is I'll just talk about the tables. So here we have our three groups. And remember, in our lab, it tells us what the groups are. One's 18 to 19-year-olds, 2 is 20, and 3 is 21 plus. So here we have 18 and 19. Sorry about that, I'm writing on this little pad. And then here I think it was 20-year-olds, but I'm paranoid enough to go look again. And it is 20-year-olds. 2 is 20-year-olds, and 3 is 21 plus. This is a more traditional age college. This is Claremont colleges, where the students tend to be more traditional ages. The oldest student I think I had there was 27, although she concealed that quite well from all the other students. She was in the post-bac pre-med program, so she had gotten a bachelor's degree and had gone off to other countries to teach English as a second language, and she came back after about five years or so of doing that. And so she wanted to go to med school, and she was in the post-bac program, and she was taking my intro psych class with a bunch of 18-year-olds in there. So here's our groups, and then we have the mean and standard deviation for each of the groups. So that's your table. You can simply put age group, 18, 19-year-olds, mean standard deviation, 20-year-olds, mean standard deviation, 21 plus, mean standard deviation. That's your table number 1. Table number 2, your ANOVA summary table. Whoops, I hate when that happens. I know it's 38. Remember, that's 38. We just add those 2 degrees of freedom above. This is exactly your ANOVA summary table. You have sum of squares, degrees of freedom, mean squares, F. And the only difference is you don't have that sig column, you just put a little star here. There's others, you actually are supposed to put 4 stars, but I'm not going to get into that with you, because with the stars you can tell how significant it is. 1 star is fine with me for this class. You're just saying it's significant. And then we have the 3 sources, between, within, and total. So this is your ANOVA summary table. It should look like this. And again, you can review that between plus within equals total. Sum of squares, between plus within, total. Degrees of freedom, between, within equals total. And then mean squares is sum of squares divided by degrees of freedom. We do it for between. We also do it for within, sum of squares divided by degrees of freedom to get mean squares. Our f is mean squares between divided by mean squares within. That's our f. And that's our table. So our table really is this. I guess I should just get rid of that. So that's our ANOVA summary table, is that. Almost looks like a flower. Now for the sentences. I'm just going to state them. I'll do the first sentences. So we'll do the post-text in a bit, which is in another output. But I'm going to give you the first sentences. So again, we'll say table 1, refer to the descriptive statistics. Table 2, refer to the ANOVA summary table. And then we have a sentence, and our next sentence is just a simple statement about whether these things are related. Well, we know that we rejected the HO. So we rejected the HO because the sig was less than 0.05. And so that means that there's a significant relationship. There's a significant relationship between the variables, and the variables is our age. So age is a predictor variable. So we have a relationship between the predictor variable age and the DV, which is how much did you sleep last night? Our DV is right here. So that's our DV. So the sentence that's next in the results is just a simple statement about, are they related? They are. So we just simply say that age was related to the number of hours somebody slept last night, comma, F, parentheses, 2, comma, 36. So degrees of freedom between, degrees of freedom within. Add the parentheses equals 9.92, that's our F here, comma, P is less than 0.05. Just like our homeworks and problems we do by hand, if we reject the HO, we end that sentence with a P is less than 0.05. We are saying that the probability of making a type 1 error is less than 5%. So that's that sentence. So we have that simple sentence saying that there's a relationship or not between the two variables. And then we have that little phrase or sentence where we say, actually, we don't have to have that sentence because we actually did the post-text. So we have to go to the post-text thing. So the F just tells us there's some difference. So now we have to go to the other output to see where the difference was. I'm not sure what that thing is doing. So part 2 of the output. Output's too big to include all of this in a nice fashion, so it's broken up into 2 parts. So now we have to look at our post-text because we found a significant effect. So since the F was significant, we rejected the HO. That allows us to look at the post-text. So this is the Tukey post-text. So even if you're not sure, you can always just look at here. It's a Tukey post-text, honest, significant difference, I think it's called. I'm a little bit tired, you can tell. And so remember with this is there's a repeat of information. So there's really just 3 comparisons, 1 versus 2, 2 versus 3, 1 versus 3. So we don't need to look at this. And we do not need to look at, we have 2 and 1 right here. 2 and 3 is a new one here. So we just have to look at 1 versus 2, 1 versus 3, and 2 versus 3. And you can see that it's just repeating. The other numbers are just the same. 2's here, 2's here, 2, 3, 8, 9 is here, 2, 3, 8, 9 here. So it's just repeating. So we're just focusing in on the things that aren't repeating. And again, the first thing I look at is significance. And again, if there is a difference between those 2 groups, so it's comparing the 2 groups, 1 and 2, 1 and 2, 1 and 3, and 2 and 3. it's saying if there's a difference between those two. So it's essentially a t-test we're doing here. And so again, we're looking for sig levels that are below 0.05. So we want to keep that 0.05 level. We don't need to worry about correcting it. The Tukey has already corrected it in terms of a type 1 error. So even though we have three things we're looking at here, we're not having a 15% type 1 error because the Tukey mathematics takes care of that. So we're looking for numbers that are less than 0.05. We have one here, and we have one here. So it looks like 1 and 2 differ. So 1 and 2 differ. And 2 and 3 differ. So 1 and 3 and 2 and 3. So 1 and 3 differ, and 2 and 3 differ. So there's something about 3, it looks like, because 1 and 2 don't differ. So the older people, well, older, relatively speaking, 21 and older, are different. And so we actually have to go back to the descriptives. So we know that 3 is different from 1 and 2, and 1 and 2 don't differ. So let's go back to the first output. And I'm just going to zoom it because I don't think this is too complex. I think you'll be able to see it relatively easy. So I want to bring it down a little bit. So we know 3 is different. So we already know that 3 is different from 1 and 2, and 1 and 2 don't differ. And that actually looks like it's true. So we have 7.4, 7.8. Those are not really different between those two age groups. But look at here, the 21 plus folks are getting a lot less sleep. And so once you find those significant differences, it's really easy just to go back to the descriptive statistics and see what's going on. And so then we can write in the end, we can write that post hocs indicate that 21 and older students got significantly less sleep than younger students. Notice I said younger. I don't have to say 18, 19-year-olds and 20-year-olds. That's just wordy. So again, students who are 21 and older got less sleep, got significantly less sleep than younger students. That would be fine. It's nice and parsimonious. So that's problem number 2. So problem number 3, we're going to look at, and if you watch the video, I explained the study. So we have groups. We have 3 groups of extroversion. We have extroverts, we have introverts, and we have in-between people, a mixture, or they're average on those two. They're not extreme. So that's our groups. And then we're asking, do those groups differ in terms of the number of best friends they report that they have? So let's go ahead and we'll go to our output. So part 3 from Canvas is the descriptives and the F-test, or are the descriptives and F-test for that problem. And so we have descriptives and we have our F-test. So again, let's just start with our tables. Table 1 is here. We have the 3 groups and we have their mean and standard deviations. That's n, we don't need the n. So that's what your table 1 should look like. It has the 3 groups, extrovert, in between, and introverts, and their mean and standard deviations. Maybe at first we'll just kind of look here, and it looks like the in-between people have higher number of reported best friends, and extroverts are not so far behind, and introverts look like they're quite different. So be interesting to see post hocs if this is significant. And like I told you before, the first thing I look for is the significance. So I did talk about table 1 first, but typically I look for this first. And so again, we're looking for sigs that are less than 0.05. That's our alpha. We're saying it's okay if we have 5% or less chance of making a type 1 error. This sig tells us the exact probability of a type 1 error, and it's 2.8%. So 2.8% is less than 5, so we reject the HO. So there does seem to be a relationship between extroversion, introversion, and number of best friends. And then, by the way, this is our Anova summary table is right here. Is exactly this. You can listen to the first question. I go over that in detail here. So we have table 1 here. We have table 2. We know it's significant. And so I'll go ahead and I'm going to interpret the first part of the results sentences. And so remember, you want table 1, table 2 is here. So refer to those two. Table 1 shows the descriptive statistics. Table 2 shows the Anova summary table. The next sentence is a simple statement. Are these things related? Well, extroversion, introversion, are they related to number of best friends that somebody reports? Well, this is what says it. There is a relationship. So there is a significant relationship between those two variables. So now we can say that one's level of extroversion significantly related to the number of best friends, comma, F, parentheses, 2, comma, 34, degrees of freedom between, degrees of freedom within, end of parentheses, equals 3.99, rounded up here, 3.99, P, comma, P is less than 0.05. P is less than 0.05, which we established here already. So we have a significant relationship here. I'm going to see if I can keep that up while I get a new snip. So we have a significant F, so we have to look at the post hocs to see what's going on. And here we go. Oh, that's not going to work. Crapola. I think the thing's behind there that I want. Yep, it does. And let us blow this up a bit, and let's actually make it big. Not sure why it had a small window there. So here's our post hocs. So again, the trick with any SPSS output is knowing what to look at and knowing what to ignore. So we're going to look at for sig, and remember that there's repeated here, and maybe it's a little bit easier because we have words here. So we're going to have extrovert in between, extrovert, introvert, and in between introvert. 3 comparisons. We already know the extrovert in between because it's right here. See, extrovert in between's right here. Extrovert, introvert's here. So this has already been there. So all we need is the in between introvert. And then this thing is, we don't care about it. It's just repeating the same information. So we're just going to look at the significance. We're going to look here, and we're going to look here. And again, we're looking for numbers that are less than 0.05. So anything that's less than 0.05, we have less than a 5% chance of a type 1 error, which is what we want. And voila. Here it is. And so it looks like there's only one difference, only one significant comparison. So it looks like that the only difference is that in between and introvert are different. So the two I's, in between and introvert, are different. Let's go back here. And we'll look at part 3 again. So the two I's are different. So it looks like the in between and the introvert are different. Extrovert doesn't differ from the other two. It's kind of in the middle. It doesn't differ from the other two. So in our sentence then, we'll say that post hocs suggest that people who are in between have more best friends than those who are introverted. Period. And that's it. That's our sentences. We're done. Oh, I'm sorry about that. We are not done. I forgot about the effect size. So you might be screaming, oh, you didn't do the effect size on the other one. Okay, yes, I didn't. So I'm going to do the effect size on this one first. So my apologies. And I'm going to snip it actually. Actually, no, I'll do the first one first. So sorry about that. Sorry about the mess up of the order. So I'm going to snip this so I can highlight what we're doing. So remember, the effect size is eta squared for the one-way ANOVA. And I'm just going to highlight this because that's what we need. You want to look at your Anova table because what you're looking at is, remember, eta squared is like r squared, which is the percent of variance in the DV that's accounted for by the, in this case, it's the PV, the age groups. So here, what you do is you take the sum of squares, that's the variance, between groups divided by total. This will give you the effect size. And I'm going to bring up my calculator, which is a little bit big here, but I'm going to put in 33.256, the sum of squares between, which is the effect of the PV. So I'm going to figure out the percent of variance that the PV explains in relationship to the total. So sum of squares between divided by sum of squares total. And voila, our effect size is 0.36. Our eta squared is 0.36. So you should have a sentence. The effect size was large, comma, eta squared equals 0.36. So 36% of the variance in sleeping last night was directly related to how old you were, those age groups. So that's the effect size for the second question on the lab. And again, I apologize for not remembering that earlier. And then we'll do it for the problem with the extroverts and best friends. And here we go. All we need is the Anova table. That's all you need. And so, again, eta squared is just like r squared, which is what percent of variance in the total variance of the DV, which is the best friends, was directly linked to the PV, the person's extroversion. So we look at sum of squares because that's our measure of variance. And so we take the between sum of squares and we divide it by the total sum of squares. That will give us the percentage of the total variance that was linked directly to our PV of extroversion. So we go here, we take the sum of squares between, divide it by the sum of squares total, and we get this as our eta squared. So our eta squared is 0.19, which is again large according to our table in our lectures. So then our sentence about the effect size is the effect size was large, comma, eta squared equals 0.19, period. And that's it. So 19% of the variance in the number of best friends was directly related to one's level of extroversion. And so I believe that finishes this lab. And so hopefully this video was useful. And I will talk to you